So let's talk about some different ways that we can represent fractions. I want to start today by thinking with you about how to represent fractions using visual models. A visual model is just a picture. So you could draw pizzas, you could draw stars in a set. You could represent fractions using visual models in a lot of ways. Very common ways to represent fractions using visual models involve different shapes. So one of the most common ways is probably this one. Just draw a simple square. They're easy to divide into equal parts. Remember, a fraction has to have equal parts. In this case, today we're going to be working with 1/3. You can see this is divided into 3 equal parts. One of them is shaded blue. Therefore, we have 1/3. Another very common way to represent fractions is with circles, especially when you're talking about thirds and sixths, things that might be kind of pie shaped. So for thirds, lots of times kids like to think of a peace sign, and that helps them divide the fraction into equal parts. Again, in this fraction, we have 3 equal parts. One is shaded, so this represents 1/3. Very similar to that circle is a triangle. Again, you take the triangle, divide it into those 3 equal parts. You can see how they look a lot like the parts in the circle. One is colored, 3 equal parts, so that is 1/3. And a final shape that we use, and this one is probably the most common. It has a lot of different names. Some people call it strip model, some people call it a tape model, some people call it a bar fraction. In any case, it's just a long, skinny rectangle. And the beauty of this as a model is that you can make the rectangle as long as you need to represent whatever fraction. It's a very versatile model. So again, in this particular case, we have 1 part shaded out of 3 or 1/3. Representing fractions using number lines is really quite simple, and it's such a useful tool. If you know how to put fractions on a number line, it will really help you add and subtract fractions and even multiply and divide fractions. So it's a visual model that's really worth your time. To represent a fraction using a number line, first draw a number line. In this case, I'm going to be working with thirds again. So I have divided my number line into 3 equal parts. Then I just add my labels. This is 0, and I'm counting by 1/3. So the next fraction is 1/3, then 2/3, and finally 3/3, also known as 1/2. And the final step is I hop on my number line from 0 to 1/3, and voila, there you have it, 1/3 on a number line. So now let's talk about decomposing fractions. Decomposing fractions, that doesn't mean something gross that happens in a graveyard. Although the words are connected, decomposing means to break down into parts. And when we decompose fractions, we find the parts. So let's get out that handy dandy bar model that we've been using and take a look at how that will help us decompose the fraction 3/3. So here's our bar model. And you can see we've got 3/3. There are a couple of different ways of looking at this. We could break this fraction down into parts that are 1/3 and 2/3. We could also break this down into 3 parts. Each part would be 1/3. 1/3 plus 1/3 plus 1/3. So 2 different ways to decompose the fraction 3/3. We could decompose it as 1/3 plus 2/3 equals 3/3, or 1/3 plus 1/3 plus 1/3 equals 3/3. Now, let's take a minute and just look for patterns. Remember, math is about patterns. Anytime you can find a pattern, it's really going to help you. What pattern do you notice in the numerators? The numerators are the top number of the fraction. What pattern do you notice? Hopefully you notice that the numerators add, when you decompose, they add up to the numerators of the fraction. So the numerators on 1/3 and 2/3 are 1 and 2. And 1 plus 2 is 3. In the same way, when we have 1/3 plus 1/3 plus 1/3, those numerators are 1 plus 1 plus 1, which is also 3. So the numerators add up to that fraction. And what about the denominators? The denominator is the number in the bottom part of the fraction. You notice a pattern there? I know you do. The denominators don't change. And that's because it doesn't matter what we're doing. We always have 3 parts. So the denominator stays the same because we have 3 parts. You might be asking one more really smart question, which is, why didn't I decompose 1/3? I've been working with 1/3 in the rest of this video. Why not stick with 1/3? Well, 1/3 is a unit fraction. That means the top number, the numerator, is 1. And we typically don't decompose unit fractions because to find smaller parts, we would have to change the denominator. It's a little more challenging. We'll get there someday. But for today, let's stick with decomposing 3/3 into these 2 parts. The last thing I want to talk about today is the relationship between fractions and division. Fractions are essentially a division problem. So let's take another very common fraction. Let's take 1/4. We'll get our fabulous bar model. And you can see in that bar model, I have one whole that has been divided into 4 equal parts. And if I want to figure out the size of just this one part, I need to divide. The numerator is 1, the denominator is 4, and essentially a fraction is saying divide 1 by 4. Divide 1 into 4 equal parts. So fractions and division are really kind of the same thing. So let's go ahead and divide that out. So to divide 1/4, I'm going to rewrite my fraction as a division equation. 1 divided by 4. You can tell this is probably going to turn into a decimal. If you're thinking it's going to be a decimal, you're thinking correctly. Decimals and fractions are very connected. They are, again, a different way of saying the same thing. So let's go back to our division problem. I asked myself, can I put 4 into 1? And no, I can't. But I know that I can add a decimal point, and then I can add zeros after that decimal point without changing the value. It doesn't matter how many zeros I add. The value is still 1. So I'm going to go ahead and just add 2 zeros. And then I can, when I'm dividing with decimals, the quotient keeps the decimal in exactly the same place. So just go ahead and put that decimal point right up top. And then I'm going to say, well, how many times does 4 go into 10? Well, that's easy. It's 2. So I'm going to divide, and then I'll multiply. 2 times 4 is 8. I subtract. That gives me 2. I bring down this 0, and now I have 20. How many times does 4 go into 20? 4 goes into 20 5 times. So I multiply. 4 times 5 is 20. I subtract. There's nothing more to bring down, and I have a 0, meaning there's no more remainders. I could keep going with as many zeros as I want, but it's always just going to be zero, so I might as well stop. Turns out that 1/4 is the same as 25 hundredths. And that's how you divide the numerator by the denominator, and you turn a fraction into a decimal.